Well, sequence, the limit of the sequence of n times an is a as n approaches infinity. And we also have this infinite series n times bracket an minus a n plus 1 equals b. And show that this infinite series an from 1 to infinity equals a plus b. And so how can we establish a relation between, for example, this series and that series, right? Perhaps we expand it n times an. But it's not that straight away useful, because a represents the limit of this sequence, n times an. But here we actually have a series where the general term is the n times an. So perhaps we first look at partial sum. Right? So partial sum, k goes from 1 to n of k times ak minus ak plus 1. And we're going to examine that. Right? Just knowing that when n approaches infinity, this will whole thing approach b. And so then we break it apart. K goes from 1 to n, k times ak minus k goes from 1 to n, k times ak plus 1 equals k goes from 1 to n, k times ak minus, this time we're going to re-index it. What if I change it into k minus 1 times ak? Right? Because this subscript is only 1 unit bigger than this number. Right? So that way I have ak. I also have ak here. So that if that's the case, k should go from, I should go from 1. So that means here I should go from 2. Right? Because 2 minus 1 is 1. So here, when k is equal to 1, right, k, a starts from a2, right? If I want to start from a2, k goes from 2, yes. So here I end at k equals n times an plus 1, right? So that way I should end at n plus 1. Right, the last term would be exactly n times an plus 1, exactly the same. So then I'm going to take out the first term of this sum and take out the last term of this sum. First term, a1. Last term is, of course, this minus n plus 1 minus n times an plus 1. We're going to deal with that later. Now I should have exactly the same, not exactly the same sum, but sum with the same starting point and ending point. The starting point should be k goes from 2 up to n, because the first term is separate. Last term is also separate. And so k times ak minus sum goes from 2 to n, k minus 1 times ak. Right, so that equals a1 minus, I'm going to rewrite this into, let me see, perhaps n over n plus 1 times n plus 1, right? Times an plus 1. So that is still the same thing. Same thing. Right? And plus, this time I can just combine the two sums. I have exactly the same starting point and ending point, right? I can safely just combine the general terms. So k times ak minus bracket k minus 1 times ak. And so it's k minus k plus 1 times ak, just ak. Just ak. All right, no problem. Just a second. And so that if I maybe put this A1 with this sum, because this sum only starts from 2, right? A1, so I should start from 1. Just get rid of it. And so that this part, right, n over n plus 1 approaches 1 as n approaches infinity. And this part approaches A, right? As n approaches infinity. But it's the same thing, right? So this whole thing approaching A. Right? A1 is already combined with this sum, but this sum will eventually, as n approaches infinity, this sum will approach what? Do we know that? No. All we know is that this sum, as n approaches infinity, approaches B. Right? So that means this whole thing eventually approaches B. So that means this sum, if it's convergent, most likely, right? This sum minus A approaching B, right? So what kind of sum if minus A will approach B? Right? The only possibility is that this sum is also convergent. Converges to A plus B. Right? Because that way A plus B minus A equals B. Yeah? So the whole thing really approaching B as n approaches infinity, right? Exactly this series approaches B. So really this infinite series, right, from 1 to infinity really approaches A plus B.